Welcome to the Pneumatics Lab. Today, we are exploring the heartbeat of industrial automation by controlling two different types of actuators together, a single-acting cylinder and a double-acting cylinder. These actuators are the final control elements that convert the energy of compressed air into mechanical motion. Let's uncover how they work. Think of compressed air as invisible muscles. In a single-acting cylinder, air pressure moves the piston in one direction and a mechanical spring automatically returns it. It's like a pogo stick that always bounces back. But a double-acting cylinder has no spring. It requires air pressure to move the piston in both directions. You use directed air force to push it out and another burst of air to pull it back. Here is the secret to controlling these movements safely. Directional control valves. They act as traffic cops, determining the exact path of the airflow. To control the single-acting cylinder, we use a 3x2-way valve. Because the double-acting cylinder needs air routed in two different directions, we upgrade to a 5x2-way valve for efficient control. Before we build this circuit, remember your safety checklist. Always verify your compressed air source, check that your pressure relief valves are set properly, and ensure all tubes are securely clicked into their ports. Grab your safety glasses and let's head over to the trainer kit.
Hello everyone. So this you can see, this is the pneumatic trainer kit. Okay. So how do I'll explain about all the components right now that are placed on this pneumatic trainer kit. This is the Siemens PLC Simatic S7 1200. This 1200 is the series of this PLC. Okay, these are the PLC digital inputs. These two blocks are digital inputs. These two blocks are digital outputs for the PLC, and these are the analog inputs. Okay, here this is the main power supply for the trainer kit. These are the what do we say, we can use this as the push buttons, and there are two panels for this. Okay, and these blue cables that we see, these are for the loopings of negative, that is 0 volts. 0 volts means through the main supply it is going to this panel, and this is 24 volts going from this panel to this panel and from this panel to this panel. Okay, so that is why the looping is done.
The trainer is doing looping. But why is this so critical? In industrial panels, establishing a common ground, the 0 volts reference, is mandatory. Without a common ground, your PLC might read false signals due to floating voltages. Safety warning: always double check your polarity before turning on the main power. Reversing the 24 volts and 0 volts will cause a short circuit and can permanently damage the sensitive PLC inputs.
Every time you have to do any connections, make sure, and this is the what do we say, this is a prerequisite that we need to follow, that these connections should be done. Okay, now how do we have to start our trainer kit? You can give, this is the power cable, you have to give it in the socket, and you can see a button right here. Okay, you can see there is no LED glowing in this button, so the trainer kit is turned off. When we push it like this, you can see there is 24 volt supply, and you can also see that there is a LED glowing, so the trainer kit is having power supply. Okay, so now we are going to do one experiment. What is it we are going to do? So here you can see I have taken two cylinders. This is double acting cylinder, this is single acting cylinder. So the aim for this experiment will be, it is very simple. So in the logic, if I have to explain you, it is two push buttons and a output. Like these are my two outputs. So one is normally open contact, one is normally closed contact connected in series. Okay, so when I push my one push button, that is normally open, when I press that, my circuit should run. Okay, this is what we are going to do, and this is the aim for this experiment. Okay, we already know that how to place these two components. Okay, how do we have to assemble them on this board? This is double acting cylinder, this is single acting cylinder. This is 5x2 solenoid operated directional control valve. This is the device that we are going to need. This is lever operated, but this is not spring written, it is like this. Operated as a lever, it has got two positions. This is first position, this is second position.
Let's break down that technical term. Why is it called a 5x2 valve? 5 refers to the number of ports, 1 for the main air supply, 2 for exhausts, and 2 working ports that connect to the cylinder. 2 means it has 2 shifting positions. Always check your port numbers carefully. If you accidentally connect the high pressure main supply to an exhaust port, you will blow out the valve seals.
Okay, this is one we are going to need. So the materials required for this experiment are 2 cylinders, that is one is single acting, double acting, directional control valve and a switch. Okay, this is the manifold we already know, and this is the FRL unit. Okay, we will be needing few pneumatic cables and few electrical patch cords. Now how you can see to either sides of the trainer kit there are patch cords. So this is according to the world scale standards. One side should be red cables and the other side should be all blue cables. You can keep it to the either side. So when I stand like this, to my right hand side you can see blue cables, to my left hand side you can see red cables. Okay, this we are going to use for our electrical connection. Here you can see we have push buttons. Okay, so in this also we have two different types. One is which holds, okay, I'm going to press and it is going to hold, and the other one is just like a push button. Okay, we need to check with that. Now I will start assembling my components. I will assemble my components in the slots. Make sure they are very firm. Okay, you can see the notch. This is the notch that I am going to assemble in this slots. Okay, you can see it is very firm. Now first initially I will start with pneumatic connection. So I will be needing pneumatic cables and a T slot. T slot is nothing but in all the three directions it will give same supply, okay, of air. Going to connect it from my manifold. First this is my input that I am going to connect. Okay, this is the first initial thing that I am going to be connecting. From here I am going to give input to this. I am going to connect my 3 cables to this T and I am going to give the supply of pneumatic. I think the wire is falling short, so I will take it near to it. Okay, I am taking it nearer. Okay, this is my pneumatic circuit. Okay, so this is my pneumatic connection done. Here we can see that there are two inlet that are there. So you can either connect it to this like this, or you can interchange according to your application. Okay.
On this trainer kit, interchanging the ports won't cause damage, but in a real factory, unexpected cylinder movement can cause severe mechanical accidents. Reversing the ports reverses the default resting position of your actuator. Never test a new pneumatic circuit at full pressure. Always start with a low pressure test to confirm the cylinder moves in the safe expected direction.
So there is no harm in giving the connection. It is not going to be wrong. you can check with the air pressure and you can decide which direction you want to give it. Okay, now I have interchanged, so my application will again remain same. I just have interchanged it. Let's do with our electrical connection. I'm going to take cables. You can use cables according to your preferences. If you want to use longer cables, if you want to use shorter cables, there is no restriction on using n number of cables. You can check the size of the cables and use them. First let's take the looping. Okay, so I want two connections, so I'm going to take 2 cables. I'll take longer ones. So if I just leave these cables like this, it looks shaggy, so I'll just put it through this hole that is being given here, so that it looks neat. Okay. So here one thing I would like to highlight. So you can see these are the positive, like 24 volts. Okay, these are the 24 volts and these are the switches. So in PLC and all, what will happen, you don't have to again give other connections, but in electrical you will have to give other say input connections and again positive connections.
A PLC internally connects the logic, so you only wire the inputs and outputs once. But in purely electrical relay logic, every single switch needs its own physical path wire. This is why electrical panels have so many wires. Always route your cables neatly, just like she is doing. Tangled cables are a fire hazard and make troubleshooting almost impossible.
So what I'm going to do, I'm going to loop it here like this. Okay. So I'm going to use smaller cables to just give my looping. So I'm going to use 2 blocks, give it here and this again and give it down. So I'm getting power supply for this particular switch. Okay, now I want to give these 2. So you can see these wires are falling short. So what I'm going to do, I'm going to use another set of cables. From here and here you can interlock them. Okay, so this is positive. I'm going to give it here. Another, I'm going to give for another side. Okay, another side. And these are the positive ones. Now I need to give to the negative ones. Okay, one I connected, another one I need to connect. Okay, so here we are done with our electrical connection. Now you can see these wires are looking a little bit shaggy, right? So what you can do is you can use small cables and you can route it through these channels. Okay, for now let's do it this way. Okay, we'll check with our connection. So now our pneumatic connection and our electrical connection is done. Let's test the circuit. Okay, I'm going to press my switch. You can see I'm getting supply. Here you can see my solenoid is actuating, but why my circuit is not working? Okay, here is the catch. So what is happening, I have used a pneumatic button or pneumatic lever you can call as my emergency switch. Instead of using a electrical switch as usual that we use, we are using here pneumatic one. So when I am going to start it, my circuit is going to work. Okay, so now let's test our circuit. I am going to press my push button. You can see that solenoid is actuated, but why my circuit is not working? So here is the catch. Instead of using an traditional electrical emergency switch, here I have used a pneumatic switch.
This is a brilliant troubleshooting moment. Why use a pneumatic emergency stop instead of an electrical one? In heavy automation, an electrical stop only cuts the control signal. If a valve spool is jammed, the cylinder might still move. A pneumatic emergency switch physically cuts off the compressed air supply, instantly freezing all mechanical motion. This is a vital fail-safe for operator safety.
Or you can, this is a lever operated, but you can call it as a switch. This is pneumatic one. So usually we use electrical emergencies, right? So here we are using pneumatic switch. So now I will just actuate it, okay, and I will do my circuit. But before that I will also release my air pressure for the manifold and to my circuit. Okay, now again I will operate. You can see my double acting cylinder, my single acting cylinders has actuated. Okay, okay, you can see when I press it again it is going to close, and when I press it again it is going to open. I will show you again. I am going to press. Okay, it is going to hold the circuit. I am not pressing and keeping it. I am not pressing the button and I am holding my hand. I am just pressing and releasing my hand. You can see again, I pressed and I have released, I have pressed and I have released. It is going to actuate. So either from this side it is going to actuate, or either from this side it is going to actuate. This is emergency stop, that is going to stop the circuit. You can see here the solenoids will stop actuating. So in this experiment we learned how to use pneumatic switches as emergency switch or any kind of switch for the circuit. Okay, so we have seen this same experiment working on the push button. Okay, this push button, how it is going to work. Okay, I will show it again, that when you press and release it, it is going to work. I'll just turn on this. When you press it and release, it is going to work. Press and release. I'm not holding my hand over there. So now we will understand with push button how it is going to work. Okay, I'll turn off my emergency. I'll turn off. Before doing any changes in your circuit, make sure that you turn off this power supply. So I will turn off.
The trainer is doing exactly what you must do in every experiment. Always isolate the power supply before modifying your circuit. If you change cables while the pneumatic kit is live, you risk short circuits, damaging the sensitive trainer kit, or worse, getting a shock. In this lab, safety is our #1 rule.
I will just interchange these cables one by one to next circuit. Okay, same, I am not doing any changes, I am just shifting my cables to one line below. Okay, I just have done these changes. Now we will check how it is going to work. I will turn on my power supply, back again. I will turn on my emergency and I have to hold my finger here. If I release my finger, it is going to go back. I have to hold my finger and press. When I release my finger, it is going to go back. So here what was happening, I used to just press and leave, press and leave. But here it is happening like press and hold, leave, it is going to go back.
Why does it go back? The first switch has a mechanical latch. It is a maintained contact. It remembers its state. The second switch is spring-loaded. It is a momentary contact. As soon as you remove the physical pressure, the spring pushes the contact open, breaking the circuit. In your wiring diagrams, we call this a normally open or NO push button.
This is push button. This was like switch. Okay. In real life, if you have to relate this to an example, this is a switch. So in your house, you turn on your electrical connection of lamps, right? So you press the switch, it toggles down and your connection will turn on. Okay, this is an example for this switch. For this push button, example is your electrical doorbell. When you press and hold your doorbell, the buzzer buzzes. But once you release the doorbell, the buzzer will stop. So this is an example for these two switches which you can relate to your daily life. Okay.